Welcome to Maastricht University. Here, researchers are working on the ET Pathfinder, a research facility that is unique in the world because it allows us to test all the important components for the new gravitational wave detector, the Einstein telescope, in a single room. Gravitational waves are created, for example, when two black holes collide. By measuring these waves, we can learn more about the origin of the universe. To measure gravitational waves, you need super-sensitive technology. Many universities and companies are collaborating internationally on this groundbreaking research. You are now standing in a student lounge, taking a break between practicals. Behind the glass, you can see the control room. Here, we run the control systems for vacuum and cryogenic cooling, which is a technique for making things extremely cold. Every day, researchers work on components for the ET Pathfinder, and soon, the Einstein telescope. Because you can't just walk into the ET Pathfinder, we do a lot of preparatory work in these smaller labs. In the electronics workshop, we design and build electronics for lasers and sensors. These components have to be extremely stable because we ultimately measure very small signals. With this in mind, researchers make their own circuit boards and electronics, which is cheaper and better suited to their needs than what existing companies can make. To measure gravitational waves, we use lasers that pass through a series of lenses and mirrors within vacuum tubes. We test combinations of these lenses and mirrors on the optic table. We also use a spectrophotometer to measure how different mirror coatings reflect light. With a photothermal cross-path interferometer, we investigate how much light a mirror coating absorbs and thereby heats up. The right balance between these lenses and mirrors, together with the tuning of the laser, is important for very precise measurements of gravitational waves. The mirrors themselves are the most advanced mirrors in the world. They are polished using innovative methods and have approximately 12 nanolayers of coatings made from special materials. In this lab, we are researching the perfect balance in coatings for these unique mirrors, everything in order to enable the super accurate measurements of the Einstein telescope. Once a theory works, we test it further in the ET Pathfinder clean room. A clean room is a very clean space where advanced equipment removes all contaminating particles, so that these particles do not interfere with the measurements. Staff and materials entering the clean room follow a strict protocol. We change into dust-free bunny suits, special footwear, hairnets, face masks, head covers, double gloves, and overshoes. Materials must also be spotlessly clean. This starts outside, where we hose down large materials with a high-pressure cleaner. They are brought inside through a double roller door. The interior is pressurized, which you can see because the roller door is bulging. As soon as the door opens, air flows out and pushes the dirt away from this space. Inside, we wipe everything clean with isopropyl alcohol and special cloths. Everything is wiped clean. Laptops, your mobile phone, and a box of 200 individual bolts and nuts. In the clean room, you can see the ET Pathfinder. This is a unique testing location for all new technologies that will soon be used in the Einstein telescope. The installation is L-shaped, with two 10-meter-long arms and 6 towers in which we suspend mirrors and lenses vibration-free. A laser splits into 2 laser beams, each of which travels through one of the 2 vacuum arms to ice-cold mirrors. This allows us to test the 2 lasers and temperatures. Around the towers, you can see the vacuum pumps and the cryogenic cooling system that brings everything down to minus 258 degrees Celsius. Everything must be clean and vibration-free in order to measure accurately. Above, you can see the entire ET Pathfinder. The towers are 6.1 meters high. This ceiling has a number of sensors to measure environmental vibrations, 4 protection rails and 4 blue winches to remove the roof of this goods reception area. We hoist large parts in through the roof. Here too, there is an optical bench, just like in the optics lab, but now in a clean room environment. It is shielded by a large curtain. Safety is important because we work with powerful light beams. We wear special glasses to protect against invisible infrared light. Without glasses, the concentrated light can damage your retina, so we are very careful. We are still working on the installation. In April 2025, we started work on the contents of the first tower, the beam splitter tower. This is the tower where the 2 arms converge at a single point and where the laser beam splits into 2 beams. From an idea in a lab to an Einstein telescope that discovers the invisible universe, who knows, maybe you will be involved in discovering the universe later on. If you would like to find out more about the Einstein telescope or working on it, take a look at our website.